is
So the easiest way to get going with a headless application is to go to the File menu, New, BlackBerry Project, Cascades, and then there are a whole bunch of templates. You're going to select the Headless app template, and this is behind the scene. This is going to do all those 12 or 15 steps in our documentation for you and give you a bare bone headless application, so you can add stuff to it relevant to your project. So I'm just going to rename it Hello. Next, SDK level 10.3, and I'm going to say yes to that. There you go. So what this did is it actually created two projects, Hello and Hello Service. Remember when I said headless application is a combination of two applications? So this Hello project is your UI application. It'll have, just a regular UI application. What a regular UI application has, like a bar descriptor, a source folder, an assets folder with all your QMLs. So just a UI application. And we're going to dig deeper to that. And it's also going to create a Hello Service app. This is your headless application. If you look at the .profile, there is no cascades here. So it's only importing LBD, BB system, and BB platform, and you can add more more libraries here if you want, but you cannot import or include the Cascades library, and that's BB Cascades. And going back to, okay, you know what? Let's look at the headless source file. What this template app does. This actually does something. So what it's first doing is setting the application setting for instant previews as enabled, so that if you do not do this chunk of code, you won't be able to show instant previews. The one kind of notification I've shown in one of my slides. So if you do this, it enables your application to show instant previews. And after that, it's simply creating a notification object, which is called mNotify in this case, setting a title, setting a body, so instant preview can be populated. And then it's creating an invoke request for the instant preview. So basically, the notification object. Let me walk over here. This is the notification object. So you set a title, set a body, and then you create an invoke request and assign that to the notification object. What happens is when the instant preview shows up, if the user taps on it, this invoke request will be executed. So I'm now explaining what this headless application does. So it's setting up that notification object and calling the on timeout. All it does is shows the notification. And so what will happen when this headless app gets launched? An instant preview is going to be shown, right? So you don't have to run the UI or anything. You install the application, and your headless application will be launched because this is actually triggered by system startup. We're going to show that. And once that happens, this headless application is just going to, first thing it's going to do is show you a notification. And if you go to the UI, you will see that the UI actually invokes the headless application from a button, and that's where this handle invoke comes in. So it handles that invoke, checks the invoke request, and then calls trigger notification, which basically triggers that instant preview after 2 seconds again. So we're going to run the application and see how it actually looks. But before we do that, let's have a look at the UI application. I'm going to start with the bar descriptor because that's where the permissions are. There you go. As you can see, there are 2 entry points defined in this bar descriptor. So this bar descriptor is for the whole application package, including the headless project, because the headless project doesn't actually have a bar descriptor. So in this bar descriptor, we're defining 2 entry points, one for the UI and one for the service. And the service, as you can see, has 2 permissions, sys run headless and sys headless no stop. So with these two permissions, it's allowed to run forever once it gets triggered. And when does it get triggered? We have to come here. You need to define this invoke target. Name it whatever you want with your reverse domain name. The invoke target type is application headless because this target is actually going to a headless application. Then you need to add this filter to this, invoke target for the headless. This filter alone basically registers you for the system started trigger. So all this is done behind the scene by the template we just used from the IDE. So you don't have to even worry about this. So you know your application is going to get launched on system started, and it's going to keep running forever until you kill it from code or the user kills it from the device monitor. Great. And as you can see, the bar descriptor also defines another filter to launch the to launch the headless application. This has nothing to do with triggers, but it's defined by this UI application, which is simply hello service.reset. That's what happens on the UI. There's a button. When you press it, this target gets launched, and then the headless application picks it up. I'm not good at explaining code, am I?
Makes sense.
Making sense?
Yep.
Okay. Because I think I'm confusing myself.
Is there any potential for somebody to put something malicious in here?
No.
No? Because it's restricted space.
What are you thinking?
I'm not sure. Did you overrun a memory or somehow corrupt the program?
In the bar descriptor?
Not in the program itself.
Okay.
Can you access memory? Can you go directly to memory from the headless app?
You can access your own. But that's all in the sandbox.
Yeah, it's not different from running normally. If you tried to read another process's memory, you'd segfault. So
Yeah, it's Unix. It's got much better process separation than, say, Linux or Windows.
And if you try to simulate the memory leak and keep defining memory in the heap, then it's eventually going to fail when it hits that 3 megs limit.
Yeah, I think you guys are certified for what, 5 minutes of downtime every 18 years or something like that? That's what I heard from the Unix guys.
Could be.
Some crazy number that no other OS has.
Yeah. Yeah, no wonder it's running so many critical things. So that's pretty much the application. The reason why I'm showing you this code is, just to try to explain everything very quickly, but that template really gives you a bare bone headless application. And you can remove all the notification stuff that this headless application is doing, but because you probably don't need them. You probably need your own notification setup and shown.
I'm curious about the no stop permission, which you said everybody has now. Does that apply with an OS update, or do we have to renew our signing keys?
Nope.
Or
nothing? So what happened is we basically ran a script on our signing server, that added that permission to all signing accounts.
Okay.
So you just have to, at best, you have to regenerate your debug token.
Okay.
That's for debug purposes, but if you sign it, it's going to sign.
Okay. Yeah. So the permissions are checked at signing time when it contacts the BlackBerry servers?
Yeah.
All right. Okay, that makes sense.
And then gets back a signing hash and then gets added to the bar file.
Mm-hmm.
All good.